So here the question is the kinetic energy of photoelectrons emitted by a photosensitive material surface. Photosensitive surface depends on the intensity. It is intensity, not intensity. It is intensity of the incident radiation. So we have to find this statement is true or false. So when we talk about the kinetic energy of photoelectrons, by using Einstein photoelectric equation, which state that the maximum kinetic energy is equal to the incident radiation, the frequency of radiation, and the threshold frequency. Okay, so threshold frequency is also called as phi. So Kmax will be equal to h mu minus phi. Here where h is Planck constant, mu is frequency of incident radiation, and also the mu naught is equal to threshold frequency. So in these equation there is no use of intensity of radiation, incident radiation. So we can say that the kinetic energy does not depend on the intensity of incident radiation. So this statement is false. Okay, that's. Thank you.
Hello everyone, let us read the question first. Two metal plate A and B, each of area 5 into 10 to the power minus 4 meters square are placed parallel to each other, separated of 1 centimeter, separation of 1 centimeter. Plate B carries a positive charge of 33 33.7 into 10 raised to the power 12 coulombs. A monochromatic beam of light with the photons of energy 5 eV each start falling on a plate A at time equals to 0. So that 10 raised to the power 16 photon fall on it per square meter per second. Assume that once one photoelectron is emitted from every 10 raised to the power 6 incident photons fall on it per square meter per second. Also assume that the emitted photoelectron are collected by the plate B and the work function of the plate A is remain constant at the value at the value of 2 eV. Determine first the number of photoelectron emitted up to t equals to 10 seconds. Second, the magnitude of electric field between the plate A and B at t equals to 10 seconds, and the kinetic energy of the most energetic photoelectron emitted at t is equals to 10 seconds when it reaches the plate B. So let us draw two parallel plates. This is plate A and this will be plate B. So according to the question, the area of cross section is equal, which is 5 into 10 raised to the power minus 4 meter square of both the plates, and plate B having charge 33.7 into 10 raised to the power minus 12 coulombs, and falling photon have energy of 5 eV. Work function of the plate A is 2 eV, and um, the number of photon fall on it per square meter per second is 10 raised to the power 16, out of which only 1 from 10 raised to the power 16 will emit the photoelectron. So let us draw all these points. This is plate A, this is plate B. This is positively charged, which is 33.7 in 10 raised to the power minus 12 coulombs. The separation between them is 1 centimeter, which is equal to 10 raised to the power minus 2 meters, and area is given, which is, and energy of the falling photon is given, which is 5 eV, and and uh, on one square on one square meter area containing 10 raised to the power 16 photon per second, out of which 10 raised to the power 6 1 from 10 raised to the power 6 will emit photoelectron. So now we have to find the number of photoelectron emitted. So first is we have to find the number of photoelectron emitted. For this, number of photoelectrons emitted. For this, first we have to find number of incident photons on plate A. So in 1 meter meter square area, 10 raised to the power 16 electrons fall. So in whole plate 10 raised to the power 16 into 5 into 10 raised to the power minus 4 electron will fall. So this is 5 photon will fall, photon, because it's monochromatic light and it's giving energy to the metal plate. So this much number of photons fall on the plate A. So this is number of photons fall on plate A in per second. So out of which only 10 raised to the power 6, 1 from 10 raised to the power 6 will emit photoelectron. So we have to divide this term with 5 into 10 raised to the power 12 divided by 10 raised to the power 6. This to determine the number of photoelectrons per second. This will give us per second. So, but we want number of photoelectron in 10 second. 10 second. So we going to multiply this term with 10. So after solving this, we having 5 into 10 raised to the power 7. So there is no SI unit because this is a number. This is the number of photons fall on. This is the number of photoelectrons. So in 10 seconds. So we are completed with our first part, the number of photoelectron emitted up to 10 seconds. Now we going to second part, the magnitude of the electric field between a plate A and B at t equals to 10 seconds. So for this we have to determine the charge on both the plates. So first, charge on plate B. So plate B is already charged, which is 33.7 into 10 raised to the power minus 12 coulombs. But due to the photoelectrons, the charge is decreased because it is positively charged and photoelectron is negatively charged. So we minus the photoelectron charge, which is 5 into 10 raised to the power 10 raised to the power 7, not 17, 7 multiply by the charge on one electron, which is 1.6 into 10 raised to the power minus 19 coulombs. So by solving this, we want only the magnitude. So by solving this, we having 25.7 into 10 raised to the power minus 12 coulomb charge on plate B, and charge on plate A is charge on plate A is 5 into 10 raised to the power 7 into 1.6 into 10 raised to the power minus 19, which is equals to 8 into 10 raised to the power minus 12 coulombs. So for final E is equals to EA minus EB, This is because this plate is positively charged and this plate gives its negative electron to this. So the electric field due to this plate is EA on this direction and EB on this direction. So these are opposite to each other, so we have to take the resultant. So we simply write sigma A divided by 2 epsilon naught minus sigma B divided by 2 epsilon naught. Sigma is equals to Q by A, charge per unit area, charge per unit area. So we can take out the common terms. So VA divided by 2 by epsilon naught A, where A is the area. VB divided by 2 epsilon naught A. So by taking the common term out, 1 by 2 epsilon naught A Q A minus QB, and after solving this we are left with 2000 and see, is the electric field, magnitude of the electric field, because the question asks for magnitude of electric field. Lastly, the last part of this question is to find the kinetic energy. So for the kinetic energy is equals to I, energy of the photoelectron, minus work function. This is for photoelectron or photoelectric effect. But in this case we have an additional energy, an additional force on the electron because of the plate B, which is already positively charged. So there is an additional term. So by solving this, 5 minus 2, this is the energy of the photons, and this is the work function, this is the energy work function of the plate A, plus 2000 into 10 raised to the power minus 2. After solving this, we having 23 eV will be the kinetic energy. Thank you for watching this video.